All right, so we're going to start looking at how to solve some two-step equations. The problem that kind of models this is thinking about going in and buying a car. So let's say the car that you wanted to purchase, it's a used car, so we'll say it's $8,000. Okay, you saved up $2,000 for that car, and the rest of it you're going to get as a loan. You know that let's say you wanted to get it paid off before you went to college, and you knew you had, let's say, 30 months in which to do that. So in this case, our unknown is our payment, right? What are we going to pay per month to make that happen? Okay. So a situation that would model that would be 30p. So 30 represents the number of months times the unknown amount of payment per month plus the $2,000 that you are purchasing the car for has to equal, I'm sorry, not purchasing the car for, that you are putting down toward the car, the money you've saved up, has to equal our purchase price of $8,000. Now, logically, if we wanted to figure out what that payment has to be, we first have to think about, well, how much do I have to borrow, right? We're paying $2,000 down, so that's money we already have paid off from the car, right? So in reality, right, we have to borrow $6,000. We take away that $2,000 from the $8,000 because that's money we've already paid. So we're making 30 payments, okay, and we want to know what's that payment have to be so that it equals that $6,000, right? And then, you know, just basic math tells us, well, if I want to undo multiplication, right, we use that division, okay, right? So $6,000 divided by 30 months of payments, right, tells us that, okay, our payment's going to be $200 a month. All right, so it's a good problem to kind of model the steps that we go through in which to solve an two-step equation. So let's talk about those steps. Okay, so in a two-step equation, give you another example here. Typically, you're going to have two operations going on, right? In this particular one, we've got addition, okay, with +3, and we've got multiplication with ×2. Okay, so those are your two operations. Another example, n over 4 minus 7 equals -4. Okay, so in this particular one, the n over 4 serves as division. Okay, and the -7 serves as subtraction. Okay, so a couple examples of two-step equations. Again, when we say a two-step equation, we're talking about an equation in which there's two operations that are occurring to the variable. Okay, typically you have one that's addition and subtraction, addition or subtraction, one that's multiplication or division. Okay, so we'll be looking at how do we go through the steps to solve these. All right, so let's start again with that first one. 2n plus 3 equals 13. Okay. So when we're solving an equation, right, we're trying to figure out the value of the variable to make that equation true. Okay, so we're trying to basically undo the operations that surround it to get it down to, in this case, n equals a number. Now, when we solve problems earlier in the year, we learned about PEMDAS. Please excuse my dear Aunt Sally, right? The order of operations. Okay, when we solve an equation, essentially we're doing that backwards. Okay. SADMAP. Sounds a little silly, but we're trying to undo it, so we work backwards through the order of operations. So our first step is to always undo the addition or the subtraction. We always take care of that first. Okay, and then as you learned when we learned about one-step equations, right, we want to use those inverse operations, those operations that undo each other. Okay, so as I look at my equation, I've got a +3. That I start with the addition and subtraction, the +3, and I've got to use my inverse to do that, right? What's the inverse of addition and subtraction, right? If I gain 3 pounds, I've got to lose 3 pounds. If I earn $3, we undo that by spending $3, and so on. If the temperature goes up 3, to undo that, it's got to go down 3. Okay, so we use inverse operations. So what I like to do on this is draw a line down my equal sign. Okay, and that just is a reminder of that idea that equations have two sides. Okay, we have to keep those balanced. Whatever I do to one side, I have to do to the other. It's just a visual way to kind of represent that. So I want to get rid of that plus 3. I do that by subtracting 3. So I'm just going to go under the plus 3 and write minus 3. Sometimes you'll see textbooks or other teachers teach right beside it. I like to just keep it as simple as possible and as little writing for you as possible. Rather than trying to rewrite the entire equation, we're just going to go underneath and write a minus 3. Okay. And again, there's that visual of the line. So since I subtracted 3 on the left, I've got to subtract 3 on the right. Now it's important as you do multi-step equations, after each step, rewrite your equation. Okay. So I look at and combine these things together, right? 2n plus 3 minus 3. Well, the plus 3 and the minus 3 make 0, right? They result in 0. So I call it zero it out. But just kind of draw a z through it. That is just that visual reminder again that it's 0. You don't need to write plus 0. We don't write plus 0. We just, again, it's canceling it out, zeroing it out. On the right side, we've got 13 minus 3 is 10. And then we want to rewrite our equation. So on the left side, I still have 2n equals 10. As we move more into multi-step equations, it's important you learn that you need to be organized, right? Go step by step through this stuff, and each step rewrite the equation. Some of these will be a little bit mental math, but again, if you kind of learn and establish that routine for solving an equation, it makes harder ones later on a lot easier. Now our last step, we've got multiplication. 2 times n equals 10. What's the inverse of multiplication? Well, it's division, right? So I'm going to use a fraction bar to indicate my division. So I'm going to divide both sides by 2. Okay. Now, in this case, we're not really zeroing out the 2. We're not turning it into 0. 2n divided by 2 is 1n. Okay, and 1's one of those we call, I guess, invisible numbers. You don't put 1 in front of a variable. We just assume when there's no number there, it's a 1. 1's your coefficient. We don't need to put the 1. So 2n divided by 2 is 1n. 10 divided by 2 is 5. Okay, and kind of the cool thing about equations is you can always check your answer and see if it works or not. So if n is 5, I should get a true statement. 2 times 5 plus 3 equals 13. Well, 2 times 5 is 10. Okay. 10 plus 3 is 13. 13 equals 13. So that one checks out. Okay. So just a quick recap. Start with your subtraction and addition. So we did that by subtracting 3 from both sides. Then we moved on to our division, multiplication. We didn't have any exponents or parentheses to deal with in this one. So we divided both sides by 2 to get n is equal to 5. Again, be organized, show your steps, rewrite your equation. Okay. Just a lot of little places to make silly little errors. So the more organized you are with this one, the better. All right, let's look at one more example here. Let's do one with division in it. So let's say we had n over 4. Let's make that -4 minus 2 equals 0. Okay, so again, we want to start with our addition or subtraction, use our inverse operation. So on this one, we have a -2. So to undo that, we're going to add 2. And again, our lines are a visual reminder of the two sides. We want to keep it balanced. So we add 2 to both sides. All right, so I've got a -2 or a -2 and a +2. That zeroes out. Okay, so we just want to get rid of that. On the right side, I've got 2. Okay, and I'm going to rewrite. So n over -4 equals 2. Okay, and then we're down to our one-step equation. I've got division. To undo division, I use multiplication. Okay, so I'm going to come over here and just write times -4. Again, we want to use a negative because the denominator has a negative in it. Division problem has a negative, and a negative divided by a negative is a positive, and we want to turn this into positive 1n. So I want to multiply by that -4 on both sides. So again, we have -4n over -4 makes 1n. Okay, we don't need to put that 1 in front. And then 2 times -4 is -8. Okay, if we check that, -8 over -4 minus 2. So -8 divided by -4 is 2. And 2 minus 2 is 0. So it checks out. Okay, so again, key steps: undo your addition or subtraction first. Then undo your multiplication or division. Okay. Rewrite, make sure we're keeping the equation balanced with doing the same to both sides. Rewrite your equation after each step, and then do a check at the end. Okay. Now, a couple things that might throw you a little bit. This is just kind of moving things around a little bit, but the steps don't change. If we put the variable on the other side, sometimes students have troubles with this, where it might be 6 equals 4 plus 2n. Okay? Nothing's changed. It's still just a two-step equation. Okay? Right? So the left and the right don't matter. Occasionally I'll have students trying, well, I got to move everything from the left to the right. But that's not what we're trying to do. We're trying to isolate the variable, get the variable by itself. So if the variable's on the right side, okay, we want to get the n all by itself on the right. So we've got to move that stuff. So in this case, I would start by dealing with the 4. Again, I want to zero that out. So if I have a positive 4, I'm going to subtract 4. Right? That would zero out. And then multiplication I'd undo with division. And I would get 1 is equal to n. Okay? So sometimes that can be a little bit tricky just because we're so used to kind of starting out, everything's on the left, but nothing changes with that. Okay? The other one that sometimes is tricky, I see students have issues with, is something like that. And the tricky part of this, and this is usually a lot of the issues that you guys will have with two-step equations, is just the presence of negatives. Okay, it creates just the extra step of difficulty. Okay, so what I usually have students have issues with on this, and where mistakes sometimes occur, is we see the plus, and we think, well, plus, right? I've got to subtract, right? But if we think about this, really what we're adding onto the n over 2 is a plus negative 4, right? And our idea is we want to turn negative 4 into 0. We want to zero that out. So how do I turn negative 4 into 0? Well, I would have to add 4, right? If I subtract 4, I'd have negative 4 minus 4, and then turn it into negative 8. But I want to take the negative 4 and make it 0, so I've got to add 4 to both sides. So then I have 12 over there, that zeroes out, and I have n over 2. Right, and then my last step is just to multiply by 2. To get 24 is equal to, those cancel out, n. Okay, if I check that, negative 4 plus 24 over 2, right, and that comes out to negative 4 plus, oops, that should be 12, equals 8, and 8 would be equal to 8, so again, that checks out. Okay, so just be a little careful with that. Again, you got to recognize the negatives, right, and understand that you've got to you're either zeroing it out, or if it's a multiply or divide, you're trying to turn it into 1n or 1x or whatever variable you're using.